You're watching video E4-p2.11, which is the psychrometer lab. I'm going to start you off with the things that you should be working on in progressing towards getting to the lab. First of all, the materials in which you're going to gather from myself or Mr. Fuzak are going to be as follows. You're going to need a psychrometer, which looks like this. You're going to need a medicine dropper. You're actually going to get 3 pieces of cotton swabs, and we'll talk about what you're going to do with these in a little bit. You'll get a small little beaker. This will hold your water. And any other things that you might be in need of will be listed down here, such as water from the sink and then a stopwatch. And you can use your iPad for that, or your iPod Touch, or if you'd like an actual stopwatch, you can just come see myself or Mr. Fuzak. We'll have that with the supplies as well. So either one of your choosing. Once you gather the materials, I'm suggesting that you read through the actual procedures that are below to have an understanding about what it is you're going to do before you even start the lab. We've noticed throughout the course of the year that a lot of people just jump right into the lab and then have lots and lots of questions about what they're doing rather than having read the lab itself prior to beginning it. So I want to make sure that you do that before you begin, and actually take a few moments and read the procedures so you have a better understanding about what is going on and what you're going to be doing. Okay, once you've done that, you're going to begin the actual lab by rereading and then following the procedures which are listed below. Once you're done with that, you'll complete the questions, which are found on page 3, right here. And there are 7 questions for you to answer. And some of them are going to make you think a little bit. Some are going to be a little bit of a challenge. So, again, if you're struggling with it, when Mr. Fuzak are up and walking around, if you have questions, do not hesitate to ask us. Okay? So, let me give you a perspective about what it is you're going to be doing and how you're going to be doing it. Okay? What you're going to do is you're going to take one of these cotton swabs and you're going to open it up. You'll notice that there's 2 cloths on both sides. You're going to open it up so there's kind of a hole between the 2 cotton swabs. What you'll then do is you're going to slide that over the bulb, which is on the top of the psychrometer. And then you also have some rubber band, which is there as well. And then that rubber band is going to help to hold that cloth on to the actual bulb itself. So the cotton swab is literally going to surround the actual bulb itself. On the back side, you're going to have a bulb which is uncovered, completely untouched. This one is going to be called your dry bulb because there's going to be no moisture connected to it. This one is going to be your wet bulb. The reason why it's going to be your wet bulb is this will be the side in which you add drops of water, as it says in the instructions, to the actual pad, the cotton swab, gauze pad, whatever you want to call it, on this side. Okay? So when you're doing that, that's where you'll add the water for the drops. Now, when you look at number 3, when it says procedure step, hold the psychrometer in your hand and slowly spin the psychrometer. This is the kind of motion which you're going to be making. Notice that it's not like really crazy, but you're just spinning around. What this is doing is it's acting as the evaporation process, helping to kind of accelerate it a little bit. And there will be a few questions on page 3 that will ask you a little bit more about this. Now, note to self, first of all, this is a thin plastic, but it does have an edge. A couple years ago, we did have a student who was goofing around and decided to swing this and got too close to their eye and literally cut themselves and had to get stitches along their eye because of that. So it happens. But again, this is not to be a joke in which you're messing around with. It's, again, a lab, so we would want you to follow our lab procedures and rules so that you're not messing around with the lab materials. Okay, you'll use the stopwatch as it mentions in step 4, and then you'll record your information as you got it, both for your dry bulb and your wet bulb temp. And then that's when you're going to be using your yellow chart. The yellow chart, which will be one of the lab materials that you will also pick up. This is, as it says right across the top, the relative humidity chart in which you'll be using to calculate the relative humidity, the percent of moisture within the air. All right. Now, in order to use this, you're gonna watch a video that that I got from one of the people I've got to know that's doing a flipped classroom as well, and he did a really good job in explaining how to use the relative humidity chart. So I'm going to take the video that he used and I'm going to have you guys watch it. and then we'll come back and we'll talk about the last procedure steps of the lab.
Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommick's Middle School Earth Science Department. Today we're going to be talking about page 12 in the reference table, your relative humidity and dew point charts. Now these charts can be very important for you to be able to identify the amount of moisture in the atmosphere, but there are some key terms that you're going to have to be able to identify. First off, that's going to be your dry bulb. Dry bulb is just very simply going to be the outside temperature. You also have your wet bulb, which is going to measure the evaporation within the atmosphere. Because evaporation is a cooling process, evaporation is going to cause a wet bulb to be a little bit less than the dry bulb. Sometimes they'll be the same, and I'll show you some examples about that a little bit later on. But the wet bulb essentially is going to be less than the dry bulb, which is going to tell us a little bit about the amount of moisture that's in the atmosphere. Once you get those two temperatures, you subtract them. That's either called the difference or the wet bulb depression. So humidity. The nice thing about these two charts, they're done identically. So your relative humidity, again, left side is your dry bulb, up top is going to be your difference. Let's give you a couple examples here. Dry bulb temperature outside is 4, wet bulb is -2. That's going to give you a difference of 6. We want to know what is your relative humidity. You're going to use your dry bulb, you're going to use your difference or the depression. So what you're going to do, you're going to find 4 as a dry bulb, 6 as a difference, follow 4 across, follow 6 down. You have a relative humidity of 14%. Well, imagine you have a glass of water that's only filled up 14% of the way. You don't have a lot of moisture in it. That's some very, very dry air. So not a good chance for rain this day. Probably had some beautiful weather. Second example, dry bulb of 10, wet bulb of 10. You're going to subtract them, you get a difference of 0. What's your humidity in this case? You're going to use your dry bulb and your difference in order to find your humidity. So you find 10 as a dry bulb, 0 as a difference, follow 10 across, follow 0 down. You have 100% humidity. You have a glass of water that's filled up 100% of the way. You have a great chance for precipitation this day. Chances are you're going to have a lot of cloud formation in this case. You have a lot of clues outside that are going to tell you that you have a lot of humidity in the air. That's the highest humidity is going to be able to get. You have a good chance for precipitation. This combination here would be synonymous with the air temperature and the dew point being very close together as well. Great chance for rain there as well. Last example, going to do a backward problem here. So you have a wet bulb of 8 and a humidity of 47%. We want to know the dry bulb and the wet bulb again. So you come to your chart, you find a difference of 8, you follow it down till you come to the given relative humidity, and that was 47%. You take the 47%, you follow it across to your dry bulb, that's 28. Now you ask yourself, what number are you going to take away from 28 to give you an answer of 8? In this case, your wet bulb temperature is always less than the dry bulb. 28 for the dry bulb, 20 for the wet bulb is going to give you a difference of 8. So that's how you're going to use those two charts. But there's a couple things that you really need to remember. When the dry bulb and wet bulb are really close together and you have a very, very small difference, you're going to say that the air is going to be saturated, which means it's going to be filled up with moisture. Humidity is going to be close to 100%. If the dry bulb and wet bulb are really far apart, you know that the air is very dry. You have a very, very little chance for precipitation here. So the numbers are going to tell you a little clue about what type of moisture you're going to have in the atmosphere.
All right, so this takes us to the last portion that I'll discuss regarding your lab, and that is completing the data table that you see currently up on the screen. What you're going to do is you'll start each of the trials by taking the dry bulb temperature, which is basically just the temperature of the air. And then after doing that, you'll add your 3 drops of water or more to your wet bulb side of it. Make sure that the water is not just bubbled up on the outside of that cloth, but also pushed into it. If you need to, use your thumb to press kind of lightly so you don't break the actual bulb itself. And then what you'll do is you'll spin it around until the temperature stops. And then what you'll do is you'll record the difference. Once you have the temperature has stopped decreasing, you'll record the difference. And that's when you'll pull up your chart, and then you'll record the relative humidity, which will be in a percent form as far as how much moisture is actually in the air. And then once you've done that, you'll go back, you'll take the dry bulb temp, add some moisture to the wet bulb, find the difference once the temperature stops, and again record the actual relative humidity using your chart. So you'll do that 3 trials, you record the averages. And what you'll do for averages is you will take trial number 1 plus trial number 2 plus trial number 3 divided by 3 trials, and that will give you your average for the dry bulb temp. That will give you the average for your wet bulb, your average difference, and then again your average for your relative humidity by simply taking the trials, trial 1, 2, and 3, adding them all together, and then dividing them by 3, and that will help you to get the actual average. Okay, once you've done that, you then have a series of questions that come on the following page. You will see that there are the questions right here in the space provided for you. There are 7 questions, I believe, and you'll just answer them: A, based upon the results that you received while doing this lab; B, some of the things that came from the notes on relative humidity; and C, just some critical thinking, some things that are going to challenge you to think about things outside of just the notes and also what you did in this lab, kind of connect the dots between some of the topics. So if you should have any questions about any of them, please find myself or Mr. Fuzak, and we'll be more than willing to help you with any of the things that you need help with. All right, good luck.